A very good evening, everyone. On behalf of the Indaca Institute of Skills, I extend a very warm welcome to all our participants, researchers, professionals, students, and geospatial enthusiasts today to offer 4 days hands-on workshop on urban planning with LiDAR, remote sensing, photogrammetry, and digital twin technologies. I hope everyone had an enriching learning experience during the last session. We sincerely thank all the participants for their enthusiastic participation, active interaction, and overwhelming response. Your curiosity and engagement made day one truly successful. Today, we move a step further into the world of geospatial technologies as we began exploring LiDAR technology and point cloud data processing. During today's hands-on session, participants will gain practical exposure to the principles of LiDAR, understand the different types of point cloud data, digital elevation model generation, digital surface model creation, and 3D visualization using industry-recognized open-source software such as CloudCompare and LASTools. These techniques are widely used in modern urban planning for terrain analysis, infrastructure mapping, smart city development, disaster management, and creating highly accurate three-dimensional representation of urban environments. Once again, we are privileged to have with us our esteemed resource person, Dr. Suman Chatterjee. He is an assistant professor in the Department of Geography at Loreto College, an expert in geospatial technology, environmental monitoring, photogrammetry, and resource remote sensing. With years of teaching, research, and practical experience, he has made significant contribution to the field through numerous research publications, book chapters, edited volumes, and presentations at both national and international conferences. We are truly grateful to have such an accomplished academician and researcher guiding us through this workshop. Now, without any further delay, I would now like to invite Dr. Suman Chatterjee to kindly continue today's session and take us through exciting practical applications of LiDAR data processing and point cloud analysis. Over to you, sir.
Yeah. So thank you so much for the introduction. And again, at the onset, I'm really thankful to Indaca for conducting this type of workshop. This is really pertinent, especially for developing skills in different disciplines. And if we want to address such critical issue like urban planning, it must be multidisciplinary. One must learn different multifaceted tools. So I'm really thankful for that. And I'm also thankful to all the participants for showing their interest in this workshop. So welcome you once again to this second day workshop of urban planning with the help of LiDAR remote sensing. So today we will be focusing on LiDAR remote sensing. For your quick reminder, last day we have discussed about the applications of multispectral remote sensing for smart city planning and for urban planning. Now, today we will be entering into something new, that is LiDAR technology, applications of LiDAR technology. And here we are not only going to discuss the application and the hands-on, but we will try to understand some basic fundamental concepts on LiDAR technology, especially related to urban planning. Okay, so without any further delay, I would like to start the session. So let me share my screen first. Am I audible to everyone?
Yes, you are audible.
Okay, thank you. Thank you
Yes,
so
sir,
much.
you are audible.
Thank you. Thank you. Okay, so I hope my screen is visible to you, to all of you.
Yes, sir.
Yeah. So as you can see here, so we will be talking about LiDAR technology and its application for smart urban planning and digital twins. So we already have discussed what is smart planning. We already have discussed what is digital twins. So we know that digital twins is nothing but a digital replica of your city or any object. That is basically digital twins. And LiDAR technology is really helpful for building this type of replica, or you can say this type of models. So let's see how digital twins can be built with the help of LiDAR technology. But before going to that workflow, before going to how it is made, how the model is prepared, let's understand what is a LiDAR technology. And this is the overview of today's theoretical session. So we will understand what is a LiDAR, how it works, what LiDAR measures, record, detects, and produce. I mean, what types of data it produces. We will discuss that. We will discuss what are the key components of a LiDAR system, focusing on the hardware part. What are the major components essentially required to obtain this kind of data? Then we will discuss the applications of LiDAR technology in urban planning and other applications apart from urban planning, not like direct application, some indirect applications we will discuss. We will also discuss different types of LiDAR system. We will understand the LiDAR data, how it looks like, what are the elements of a LiDAR data, what is the format of a LiDAR data, and we'll also see some of the LiDAR data sources from where you can actually obtain or acquire some of the open source or freely available LiDAR data. That we will also see. We will also discuss what are the different LiDAR data processing steps, or what are the options we have regarding LiDAR data processing. We will also discuss what are the tools available here, tools and software for LiDAR data processing. So that's all. That's all about theoretical session. After this, we will jump into the hands-on part. Okay, so I hope all of you are ready to learn something new. So let's start today's journey. So what is a LiDAR? So all of us know the abbreviation. What is a LiDAR? That is light detection and ranging. Okay, so this is the abbreviation for LiDAR. And within this abbreviation, you can, it is actually kind of self-explanatory. Light detection
Sir,
and
cannot able to hear
ranging.
anything.
Sorry, am I not audible?
Sir, we can hear you.
We can hear you.
Okay, so, okay. So, this word explain everything, light detection and ranging. So what does it means? Actually, it detects object. It estimate the location by ranging. Ranging means measuring the distance between the sensor and the object. That is basically ranging. Just like you have GPS or navigational satellite system, that also, you know, work on pseudo range. But GPS or GNSS, they utilize some different wavelength range or radio wave. But here in this technology, it utilizes laser pulses. But at the end of the day, it measures the distance. And with the help of this distance, it can estimate the accurate location. That means it can estimate the X, Y, and Z value. That means latitude, longitude, and altitude value. So with LiDAR technology, you can precisely estimate the X, Y, and Z value, and it can measure the distance between the sensor and the object. And also, with the help of some other auxiliary processing, you can also detect feature. You can also identify feature, that whether it is a tree, or is it a is it a building, or is it the ground, or it's something else, canopy. Okay, so that detection is also possible. So that's why light detection and ranging, it measures the distance, it estimates the coordinates, it can detect the object. That is all about LiDAR technology. Okay, and definitely with all this data, it is capable of producing 3D map or 3D objects. Now, how it works? So as you can see here in this diagram, so if you carefully see, so there is a
Dr.
sensor.
Chatterjee, I'm very sorry to interrupt you. May I have 5 minutes of your time, a little privately? I will have a personal question of mine.
No, actually, this is a session for everyone. So we will have a interaction question answer session, but not now because this.
Actually, this question was from day one. Actually, I told my parents about the workshop and all. So the thing is that my parents have a NGO. Okay, so we do human elephant conflict mitigation program in Maharashtra and Odisha. So my
See,
question, I
I
would
can
like to.
understand what your concern is, but please try to understand that this session is for everyone. So if you want to talk to me regarding anything, you can call me anytime. You can communicate with me anytime, but not in between the session because you have a limited time with for the session. We have activities. So we will have a session for question answer. And furthermore, if you can also contact with me after that if you have any queries. But if you have any queries regarding today's session or last day's session, you can definitely ask during the question answer session. But it actually hampers the continuity. So I kindly request you to please address your query after this session, or after you can also anytime you can communicate with me. Is it
Okay,
good?
sir. Then can I have your contact information?
It is there in the WhatsApp group. Okay, you are
Okay.
in the WhatsApp group, so it is there.
Okay, sir. Okay.
Okay. Thank you so much for
Thank you. I'm very
understanding.
sorry for interrupting
No, no,
the
no, no,
class.
no, no. No, not an issue, but I'm also thankful to you for understanding the issue. Anyway, so let's understand how LiDAR works. So you can see here, this is the sensor and this is the scanner, all mounted in one platform. Maybe other sensor can be also mounted like any RGB scanner or camera. That can be also installed or mounted on the whatever platform you are using. You might be using UAV or drone, whatever you are using. Now, laser pulses or energy is emitted at an interval of particular time, and it is directing towards the surface. Now it might be hitting the canopy, maybe the next layer of the canopy, the branches, and finally it might hit the ground. Okay, and then this beam, we call it laser beam. So this beam is reflected back towards the sensor after hitting each surface. So first it hits the top layer, then is reflected back, it reaches the scanner, and same process happened for all the all the beams. Okay, and the scanners actually record everything. And mind that whenever laser pulses are emitted, they are also look embedded with location, GPS tag, and also time stamped when they have, I mean when they are emitted. Okay, so with all those information, scanner can record the number of return or beam or reflection, whatever you call, and also from where it is coming. Okay, that way it can actually measure the distance between the object and the sensor, and with the help of that distance it can estimate the X, Y, and Z, and also it records the amount of energy is coming from any surface, whether it is a top, whether it is a branch, or maybe some other layer of the canopy, or maybe from the ground. Okay, so it also record the intensity, the amount of energy coming reflected back from the surface. Okay, so intensity is recorded, XYZ is estimated, distance is also measured. Okay, so that is how LiDAR works. Now, what LiDAR measures, record,
Dr.
detect.
Suman, and just one question here. This only works on the solid
surface, or it can work with a liquid also?
No, because LiDAR utilizes, electromagnetic radiation, laser beam, which is coherent beam. So it is mostly applicable for something, having solid surface. Okay, because for underwater, application, you have to use other type of radiation. So it is for solid, actually.
Okay. But it can detect different type of services, right? So
Absolutely.
it can detect the branch, it can detect the canopy, it can detect the bottom.
Yeah. But not like how multispectral detect, because multispectral detects based on the spectral information, based on the pixel value, digital number value, and signatures, but it does not utilize this. It utilizes the distance, and from where it is actually coming back, it calculates the distance, and there are some algorithm for classification it utilizes, and then it classify the points. Okay, so it does not work like multispectral. For multispectral, signature is important, but here, from where it is coming, that is important. Okay, so now what LiDAR actually measures: record, detect, and produce. Okay, so LiDAR measure the distance. That is why it is called ranging. Then it estimate X, Y, and Z coordinates. It record the intensity of the return beam. It also store the return information, like how many beams are coming back, how many reflections are coming back. We call them echoes. Okay, in LiDAR, we call them return or echo. Okay, so how many echoes are coming, after what interval. Okay, and timestamp is also recorded. So all these informations are recorded as return information. And finally, based on all this information, location, distance, it classify different returns. And this classification actually leads us to detect different surface. We will understand how this classification occurs. So the first thing is ranging or measuring distance. So that happen really in a simple manner. It utilizes a very simple functions. That is, it utilizes the speed distance relationship, speed distance and time relationship, because it is an electromagnetic radiation which has a constant speed of every light beam, that is 3 into 10 to the power 8 meter per second. So utilizing that information and utilizing the time of flight, what is the time taken to travel the distance, utilizing that information, it can calculate the distance. So you have speed of light, you have time of flight, and with the help of these information, with simple equation, it can calculate the distance. So LiDAR is a ranging system that calculates the distance between the sensor and object, often used to measure a plane's altitude. The system determines the exact location of LiDAR sensor using GPS and orientation of the emitted LiDAR pulses, and that is recorded using an IMU, that is inertial measurement unit. We will talk about different components of LiDAR. We will understand that what is IMU. Now, definitely it just cannot use any type of electromagnetic radiation. It must be laser. Laser is something which is having coherent wavelength. All the wavelengths must be coherent, having the same kind of phase, similar phase characteristics of each of this wavelength, making it coherent, and it is unidirectional. So that's why it can easily hit the surface and can get reflected back. And there are some principles we use, like pulse duration. I told you that laser emission is kind of a pulse emission. It is not a continuous thing, just like scanning, multispectral scanning, that is a continuous thing. But for LiDAR, it is not continuous. There are pulses. So they emit pulses at a particular time interval. So that is called pulse duration. The number of pulses emitted per second is called repetition rate. And pulsed laser can deliver very high peak power because of the energy is concentrated in very short time. That is called peak power.
Dr. Chatterjee, I wanted
Yeah.
to ask a question on this peak power. It is saying that pulse lasers can deliver very high peak power because the energy is concentrated in a very short interval of time. So my question is that when the LiDAR is being used on a particular thing, say suppose it is scanning crop field, say suppose, and there are animals. If the LiDAR is too much powerful for the electromagnetic and the laser, is it too much
Yeah.
harmful on the animals over there, or is it a very concentrated power?
It is coherent but not harmful for any for plant or animal. So the pulses are not cannot generate much heat or such type of harmful effects. Definitely it is concentrated and coherent, but it is not harmful unless it is directly coming into your eyes or someone's eyes. So it cannot generate that amount of heat which might be harmful. So no, it's not harmful.
Okay.
Because for plant study, for different purpose
Yes,
we use
that
light.
was actually my base question actually on
Yeah.
bit of an environmental question actually.
Yeah. I understand, but it is not harmful.
Okay.
Okay. So the next thing is, what are the key components of a LiDAR system? So although there are many small things, small chip, IC, different things are there, but if we categorize, there are mainly four components we have in a LiDAR system, irrespective of wherever you are using it. Is it a terrestrial or aerial? But there are mainly four components we have. First of all, you have a laser that is generating the pulses and emitting the pulses. Then you definitely have a scanner which is doing the opposite thing, recording as recording the pulses. Then you have really important thing, that is component, that is GPS, any navigational chip. There are mainly two types of modules are installed. One is for telemetry, another one for recording coordinates. And then you have IMU, that is inertial measurement unit, which actually detect and measure the types of changes happening, modulation is happening regarding the platform. Whatever platform is being used, whether it is a drone or any other type of UAV, what types of maneuver is happening, what type of inclination is happening while it is moving, that information is stored in IMU, which is again used for calculation of XYZ and distance measurement, because it is essential to know how a particular platform is moving, inclining, tilting. So we define this movement mainly using three types of movement known as roll, pitch, and yaw. So the IMU actually stores the amount of rotation along the roll axis, pitch axis, and yaw axis. Okay, so IMU store all this information, and those informations are used for calculation of XYZ coordinate, and also for the ranging purpose. So these are the major components.
Sir, one question.
Yeah.
Sir, when we will capturing the data on the mobile LiDAR system, so when we will go with the tunnel, what GPS is not working there, how to calculate the XYZ in that area?
Yeah, that is a good question. Sometimes GPS, fail to work. It must be mounted with a good, GPS system. However, if it fails, then you must, have some post-processing workflow where it can actually, produce the missing points where the location was not, stored due to the non-functional of GPS. So there is a post-processing workflow there for this purpose only. Whenever GPS is not working for some points or maybe for a particular area, so you have to, run through the data with a dedicated software which can actually generate this point with the help of other, ancillary data. So yes, sometimes GPS does not work, but there is a, foolproof system, post-processing system to, retrieve all this information.
Okay, okay. Thank you so much.
Yes.
So this
So these
IMU,
yes,
IMU,
IMU stands for Inertia Measurement Unit. It actually measures the roll, pitch, and yaw movement of any platform. Okay, I have not included this because it would, increase the, slides. But if you want, I can explain you what is roll, pitch, and yaw.
no,
If you
I just want to know, like, on a high level, what is the function of IMU? GPS, laser, and computer, I understand, but
yes,
what is the purpose of IMU? Yeah.
good question, good question. See, whenever a platform is moving, it might be a drone or might be any other type of UAV, but whenever a platform is moving, there might be some instability, some maneuver might be there. So due to that reason, a platform might tilt along its vertical, nadir axis, or maybe from nose to tail axis, it might rotate. Okay, it might need to change the, path, the flight line. Okay, then it might need to rotate along the wings axis. So all this, change in position, this information is really important, because you're also this along with the platform, all the systems are also, changing its position. That's why how a platform is moving or maneuvering or tilting or rotating along its nose to tail axis or maybe nadir axis or maybe wings to wings axis, that information is really essential for, estimation of XYZ and also estimation of the range. That is why IMU is installed. That is the function of IMU. And I hope you have understood. And
So basically, it is helping in adjustment of distance if it is not very linear, right? Something like that.
yeah, whenever see, there might be a wind flow or wind shear.
Mhm.
So a platform might get instable. So there might be a rotation along the wings axis or maybe the nadir axis. So that, deviation of that information must be recorded. At what point of time it got deviated, it got tilted or rotated. So that information is vital for, LiDAR system to work. So that's why IMU is helpful. Now, the computer is definitely process the data, calculates the distance, and it produce the raw data. Then again, post-processing also works.
Okay. Good. Thank you.
Okay. Now, as I discussing that the objects are identified based on the return information. So return means whatever is coming back, the reflection. So you can categorize the return into first return, which one is just striking the top of the surface or top of the canopy and coming back, that is first return. Then in the next layer of the canopy, you have second return. Whenever the beam is striking the third layer of canopy and it is coming back, that is third return. So you have multiple returns starting from the first return, second return, and last return will be definitely from the ground. Okay, so based on different types of return and how many returns are coming back, so we can classify the data that this type of return can comes under, is coming from the canopy. This one is coming from the branches, and this return is coming from the ground. So that's how we can categorize. So return information is stored as per, we have two dimensions for storing return information. One is return number, another one is number of returns. So there is a difference between return number and number of returns. So what is return number? Return number indicates the sequence position of a particular return within a pulse. For example, the first return, the second return, the third return. So this 1, 2, 3, this is actually return number. Okay. So first return from tree top, second return from branches, third return from ground, which is also, you can take it as last return. Okay. So when you are numbering this return as per their, level from where they're coming, so that is actually return number, first return, second return, third return. Now you again have number of returns. So what is number of returns? Number, how many returns is coming? That is basically number of returns. It indicates the total number of returns generated by the same pulse. Okay. For example, if a pulse produces 3 returns, each point will have number of returns is equal to 3. So that is basically number of returns. It is also called as echoes. So first echo, intermediate echoes, or last echo. It is similar to, first return, second return, or the last return. Now, let's talk about the applications of LiDAR technology in urban planning. So there are many. So I have tried to list some of the important applications. Like it can produce high resolution surface model, like digital elevation model, digital surface model, digital terrain model, and it is actually, it can build the digital twins or 3D city it can build, and that is basically the digital replica of the city. It can helpful for urban infrastructure planning, as it is helpful for building the 3D model of the city or digital twins of the city, which can eventually help in infrastructure planning. Okay, like wherever anything dispute is there, it can identify, or it can help in planning. It can be also useful for flood risk assessment and stormwater management, because it can produce surface model, and surface model are essential for flood risk assessment and stormwater management, which is a really critical problem for many cities. Now, green infrastructure and urban forestry, definitely it can measure the canopy height. It can useful for biomass estimation. That's why green infrastructure and urban forestry, because it can detect the object. That's why it can detect the building. You can extract the building. You can extract the vegetation area. Okay, so we will see that in hands-on. So this is how it can be useful for green infrastructure and urban green space and urban forestry planning. It can be also useful for building information modeling, and definitely to build a digital twin platforms. Apart from this, conventional urban planning applications, you also have other types of application, like it can be used for autonomous driving. So LiDAR technology can be used for autonomous driving, because it can measure the distance and it can tell you what is the situation surrounding a particular car. So which can be again integrated with IoT and with the AI, and that will make this technology work, like autonomous driving. It can be also used for robotics and facial recognition. So these are some of the important applications of LiDAR technology. So there are two types of LiDAR system. One is airborne LiDAR, and the second one is terrestrial LiDAR. So definitely airborne means something which is flying above the surface, and capturing the data like UAV or drone. And terrestrial LiDAR means something mount on the any tripod or any station on the ground, on the surface. And it works similarly, just it is mounted on aerial platform, or something is mounted on the, on the ground. So this is the basic difference between airborne LiDAR. Some are also, some can also categorize this as mobile LiDAR, which is moving. Okay. So this is the major category: airborne LiDAR system and terrestrial LiDAR system. Now let's talk about the LiDAR data, the most important thing, because we are not going to field or capture the data. Instead, we will have the ready-made data, and we have to work on that. So it is better to understand the data. So in LiDAR data, what we have the distance information, XYZ. I already have mentioned many times. It record the intensity and the return beam, return information, and classify the returns. Now, very important, this is really very important. So how a LiDAR data appear to us? How it appear to us? So unlike multispectral data, for multispectral data, you have seen that it is captured in different bands, and each band can produce one image, digital image, consisting of pixels. So its smallest unit is pixels, smallest entity is pixels. But here, for LiDAR, it does not produce any image. Instead, they capture the data in discrete points. Okay, so it captures the data in discrete points. So you have numerous points, millions of points. Okay, so many points, and each individual point have multiple dimensions. We will talk about that. What are the dimensions? And since we have so many points and millions of points, it actually form kind of a cloud. And if you see from a distance, like if you are not zooming the data enough, it might appear to as continuous, something as image, but it is not actually an image. If you zoom to sufficient extent, you will be able to see individual points. So an individual point will be having multiple dimensions. Okay. So that is how LiDAR data is captured and recorded. It is captured in point cloud format. So point cloud is a collection of discrete data point in 3D space, representing the shape of surface of an object or environment. Sometimes the points are very sparse, which is called sparse point. And if the points are densely distributed, it is called dense cloud. And remember, this point cloud concept is also useful in photogrammetry. Photogrammetry, they also use point clouds, the same type of data. Okay, so let's talk about LiDAR data format. So I discussed that, I mentioned that each point have different dimensions. Individual point have different dimension. So these are the dimensions you have. Okay, so X, Y, Z, we know what is X, Y, Z, longitude, latitude, and altitude. Furthermore, you have more dimensions. It is just, we have mentioned few of them. It might record more dimensions like ID, GPS timestamp, and many more other information we will see. So mainly they record X, Y, and Z along with I, N, R, C. So these are the dimension I, N, R, C. I means intensity, the intensity of the reflected laser pulses or reflected beam. N means the number of returns, and R means returns number, and C means classification. Okay, so this is the dimension we will be having when we will be dealing with point cloud data. So each point will be having X, Y, Z, intensity, number of returns, return numbers, and classifications. So with this code, this number in classification column, this can actually tell you whether this is a vegetation or it is the ground or this is a building or something else. So that can be identified with the help of this number, this classification number. And there is a definite standardized code for this classification number. We will talk about that. So these are the dimension I already mentioned. X, Y, Z represent the spatial coordinates. I represent the intensity, that is the strength or intensity of returned laser signal. And N is the number of returns, represent the total number of echoes received from a single emitted laser pulse. R is the return number, that is that indicates the sequence or the order of each return among multiple echoes. Okay, and the C is the classification, whether it is a ground or is it water body or building. So that can be identified with the classification code. So here you are seeing a screenshot.
Does the civil structure like tunnel or bridge comes in as part of building or what?
Yeah, it will comes under any building or man-made structure. So the code for this, particular object will be 6. So there is a standard code. So building, any man-made structure like tunnel, so they are coded as number 6. If it is a vegetation, that is coded as 3, 4, and 5. Low vegetation, and there are other categories. So you have different number coding for each type of object. So any man-made object, elevated object on the ground, which is man-made, it can be a tunnel, bridge, or maybe building, roof, or monument, that can be counted as 6. That is building. So these are the other dimensions recorded during data processing. I told you it is not only about X, Y, Z, I, N, R, C, but also other informations are also recorded. So this is a screenshot I have taken from the software. You will also see when we will be doing the hands-on part. So you can see here X, Y, Z is recorded, intensity, return number, number of returns, scan direction flag. This is also recorded. I told you that each pulse is this timestamp, that is also recorded. GPS information is recorded. So many other information is recorded while they are storing the data. So you can understand all this information is applicable to a single point. So each point will be having all this information. Now, again, it is not about 1 or 2 points or 3 points, millions of points. So you can understand the heaviness of the LiDAR data, how heavy a LiDAR data. So that's why most of the time we need to segment it out or taking some part to study, because if you take the whole scene or whole data, and if you don't have enough processing power, so it might take some longer time. So we usually cut out a portion and then we study. Now, just like for the multispectral data, you have TIFF or IMG format file extension. For vector data, you have .shp, or for other type of data, you have AOI, okay, ASCII format. Now here for LiDAR file extension, you have some very commonly used format, that is LAS file or .las, LAS, and .las, LAZ. So this is the common file format for LiDAR data handling. So LAS format is standardized and widely used, and these formats are developed by American Society for Photogrammetry and Remote Sensing. So they have standardized this format. Not only this format, but also the code classification code that I was talking about. That standard code was also developed by this American Society of Photogrammetry and Remote Sensing. So these are some of the common LiDAR file extension. However, we mostly 90% cases we handle the LAS and LAZ format. LAS is the standard LiDAR point cloud format, and LAS is the compressed one. It is much more structured. It is compressed. So LAS is something loosely, compressed or built, kind of a raw data, but LAS is compressed one. So these are the commonly used file extension for LiDAR data. LAS, it stands for Laser File Format. It is a standard binary format created by American Society of Photogrammetry and Remote Sensing to store 3D point cloud data. Okay. So although it is called 3D, but you have seen that you have multiple information, not only X, Y, Z, but also other I, N, R, C, and many more. LAS stands for LAS zip file because it is compressed version of the standard LAS file. And LAS file are typically, 7% to 25% the size of original LAS file, because I told you that you have so many points, millions of points, so data become really very heavy. You also have another type of, much more restructured and standardized format, that is LAS COPC. COPC stands for Cloud Optimized Point Cloud. It is a special type of cloud optimized variant of LAS format that is also used in many cases. So we will encounter only LAS, LAZ, and LAZ COPC file extension. Now, this is the classification or coding by American Society for Photogrammetry and Remote Sensing, that is I was talking about earlier. Classification of different surface or feature and coding. So you must, memorize this one. It will be really helpful if you're working with LiDAR data. So if you memorize this coding, that will be really helpful, and it is standardized. And for majority of the data, 90% LiDAR data, it will have the same coding. So for ground, it is usually more than 1 to 2. It is coded as 2. If it is a vegetation, it falls under 3 to 5, 3, 4, and 5. 3 for the low vegetation, 4 for the medium vegetation, and 5 for the high vegetation. If the code is 6, that is for building. 7 is for low point and noise data. There are many noise in the data. Okay. And you have water body as 9, and other, overlaps, reserved, and other things. Okay, so this is the standardized coding by American Society for Photogrammetry and Remote Sensing, and you must remember these codes.
Sir, 8 number point.
Yeah, 8 is a mass point. Sometime, it is unable to detect, specifically any feature. That those are, marked as model key points. Okay, we will see during the hands-on. We will see. We will, change the value, and we will see what features is coming under a particular code.
Sir, there's actually another question that I had. Like, on what is the basis on which this classification is made? Like, is it, I mean, to understand whether a feature is of a particular land use, or like, I mean, only one point cannot be considered, or is it? I mean, a few surrounding points would also have to be considered to understand the feature, wouldn't it?
Yeah. Many points are, considered to classify any particular point, but the main principle here is the distance. Whenever the return is the last return, it can be classified as the ground. Okay, and whenever is the, top, it can be a canopy depending on the distance or the height of the object, or it might be a building. Okay, so there are different classification algorithm we will discuss. Let me show you. Yeah, you have different classification algorithm. The software classify the points using different rules and algorithms like ground filtering, height above the ground, slope and neighborhood shape, surface continuity. Based on all these algorithms, the software actually classify the points, and it denotes the numbers. So it is based on the return information mostly. For multispectral data, you have digital number and signature and spectral information. But for classifying the LiDAR data, the major help aid here is the return information. Okay, so return information definitely consists of multiple, returns, as you were mentioning that multiple points are required to, detect a particular type of return. Okay, so that is the main principle of classifying.
So these data sets have like some kind of a classification already built in,
Yeah. For
like
most of the
yours.
data, data distributor, they actually classify the data and provide you, classified data. So in most of the cases, you already have classified data.
Okay,
Okay, so
thank
you
you, sir.
already have coded data. But in case, suppose you are launching any project, you have a LiDAR sensor, so you also must have that, computation or the, software to produce the classified, data. In case you are running any drone, you have installed one LiDAR sensor. So there will be a computer or processing unit, and also post processing will be there. So during that post processing workflow, you must have that particular dedicated software which can apply these algorithm to classify the points. Okay, but usually the data distributor, they provide the data with, in classified version. They already coded the data. Every points they have coded that this point is 3, this one is 4, this one is 5, this one is 6, and so on. Okay,
Okay, thank
so
you.
yeah, thank you. And these are some of the LiDAR data sources. Mostly, most of the, I'm talking about the free sources, not about any, paid one. So if everything is open source, I'm talking about here. So for regarding open source and free data availability, you might not have global, coverage. For some projects or mission, it has, a specific coverage like USA or some like Scotland or any other specific uh, coverage. So you can definitely download data freely from this website, but not for our country. So for our country, there is no free source from where you can download. You might you know apply or put requisition for from any project conducted LiDAR project, but freely available LiDAR data for India is not available. And these data, this website, you can definitely download a huge, uh, diversity of data from this website, because it has a very large coverage, and these are really helpful for learning purpose. It is helpful for learning purpose, and if you are planning to, go with a project for your region in India, then you have to either run your own, drone or LiDAR sensor system, because in India LiDAR data are not freely available, except few, website like Open Topography might have few data available for India, but you cannot obtain whatever you want for your, region. So you have USGS National Map Downloader, you have Open Topography, USGS 3DP, you have Global Ecosystem Dynamic Investigation Portal, NOAA Digital Coast, and Scottish Remote Sensing Data Portal. So you can use this portal to download any LiDAR data for that particular region. Okay, so there is some, everything is not bad. We have some free data. We can, learn how to process. So what are the processing? So LiDAR data processing have mostly these workflow incorporated. First one is data quality check. Second one is removing the noise, extra unnecessary points. You can remove them. Then slicing and segmenting is really important, because I told you that LiDAR data is really huge collection of points. So you must, cut out a portion that is called slicing or segmenting. You can in GIS you might call it clip or subsetting, but here you call it segmenting. So a part of the point cloud you just cut out and study. So that is helpful because we have some limitation in software. Some softwares cannot process beyond 2 million points or more than that. So you have that limitation. That's why if you want to produce some raster data from point cloud data, you must first create the segment, or you must slice the data into some segment. So that is slicing and segmenting. Then finally you classify the points. You already have classified coded, you just have to extract them. Then feature extraction, and you produce raster surface, that is surface modeling, digital elevation model, digital surface model, and digital terrain model. I hope you know the difference. Digital elevation model is basically we are talking about the terrain, the elevation of the terrain. Surface model is something which add other object on the ground, not only the terrain but also man-made object or maybe a forest or other canopy. That is basically surface model. And digital terrain model is synonymous to digital elevation model. And finally you can export the whatever result you have produced. So this is the basic workflow you can see in any LiDAR data processing. Yeah, again I'm describing this. First you acquire the LiDAR, raw LiDAR data collected by aircraft, drone, or terrestrial scanner. Then point cloud is registered and cleaned. Then there are software which actually classify the points using different rules and algorithms such as ground filtering, height above the ground, slope and neighborhood shape, and surface continuity. Then there are manual editing by analyst. And finally they create the LAS file or the LAZ file, which the end user will be using the LAS file or the LAZ file for further analysis, for canopy height modeling, for building extraction, for vegetation extraction, for producing DAM, DTM, DSM, and many more, for creating digital twin and so on. So that is basically the pre-processing workflow, you can say, because these things happens before you produce the LAS file. Now let's talk about different LiDAR data processing software or tools we have. Many are commercial software which are not free, but good news, there are some which are free, like the one we will be using, that is LASTool and CloudCompare. We will be using these two tools. And some of the tools and utilities are free for LASTools. Not all the utilities are free for LASTools. Some are commercial, you require license, but definitely some major important tools are there in LASTools which are free. Okay, so you can also use QGIS. We will be using QGIS, Global Mapper, MicroStation, TerraScan, and ADAS Imagine, which is a commercial software we all know about, remote sensing software. So these are some of the common tools and software for LiDAR data processing. So what we will use QGIS, we will use LASTools. I hope you know that. And we will use CloudCompare for LiDAR data processing. Now, these are the tools which are open source and licensed in LASTools. You can go through this later. So some are commercial, some required license, and some does not require license in LASTools. So I have listed here. So thank you so much for paying attention. That's all for theoretical session, and we will jump into the hands-on session. Before that, I will give some time to you, like 5 minutes, that you can be ready with the data I have already uploaded in the day 2 folder in the drive. And if you have any questions and queries, so I'm here. And I
Doctor,
also, yeah, please.
what should I install this cloud compare
Yeah,
and
let me help you regarding this. You have to install, you already have QGIS. Now you have to install LASTools first and then CloudCompare. Okay. And you can have this software. Let me just, yeah. So all the softwares are inside this folder. So you download this one, LASTools. Okay. Everyone, I hope all of you have downloaded LASTools. And you also download this one, CloudCompare. And I hope you already have QGIS because last day we have worked with this. So LASTool and CloudCompare, please download this, this tools. Okay, this folders, you download this and I will tell you how you can install the LASTool first. Let me just give one thumbs up that you have already downloaded this, this folders or files. Have you downloaded? Okay, so you download these files first and we will see how to proceed with the softwares, how we can install the LASTools. And CloudCompare is really simple. You can directly double click the exe file and it will ask you to for next, then it will be installed. But for LASTools you need some assistance how to uh, install this software. So please let me know whenever you have downloaded the LASTools and the CloudCompare. Okay, so yeah, thank you for letting me know. And others also, please let me know whether you are ready with your tools or not. Then I will show you how you can install the LASTools.
Dr. Chatterjee,
Yes.
can I ask my question now? What I want to ask
Yeah.
earlier.
Yeah.
Uh, so if we have data set of latitude and longitude, and if we import it as a CSV file in QGIS, how do we
Right.
get different layers in QGIS to do a study on forest cover, especially on the elephant occurrence distribution map for conservation management framework, priority management zones, core
Can
elephant
you
habitat
repeat your
zone?
question, the last part, especially the last part? I understood that you want to import the CSV file with X, Y, and Z locational information. And then I didn't understand the last part.
So, I actually wanted to ask this question based on human-elephant conflict zones, actually. Core
Okay,
elephant habitat zone, movement corridor zones, and all.
okay,
I
okay.
don't know if you have idea on this.
Yeah. Yeah, go on.
Hello?
Yeah, go on, go on. Ask your question.
Yes, so I was asking that only. So it is actually for the latitude and longitude data set. We wanted to put in elephant occurrence distribution map for conservation management framework or priority management zones. Say suppose a core elephant habitat zone, movement corridor zone, human elephant conflict buffer zone, or habitat restoration zone.
Yeah, okay, got it. Then,
So, sir,
so what
yes,
is your
sir. That is
question?
this was the question only actually.
Okay. So, you want to import the
A
data of,
CSV file from in QGIS for
yeah,
this particular topic.
yeah, understood. So you have CSV file. There is X, Y, and elephant occurrence data, right?
Yes.
Yeah. Then you import that as point file. So you have a point file in QGIS. right?
Okay.
So with that point file, you also have one attribute of elephant occurrence,
Okay.
right? So now you can definitely go with many, vector analysis. Definitely you can go with buffer analysis, right? You
Hmm.
There is a specific type of GIS analysis for this type of work. Okay, we call it corridor. Under network and connectivity analysis, there is a analysis called corridor analysis. Okay,
Okay. Corridor
and
analysis.
yeah. And then you definitely can perform buffer analysis, and there are many, let me tell you. You can also go with measuring geographical distribution to understand the spatial pattern, okay, of the elephant occurrence, to understand the spatial, accumulations of elephant occurrence. Furthermore, you can go with, spatial autocorrelation uh, analysis, which can tell you whether is there any hotspot zone or cold spot zone. Okay, so with global spatial autocorrelation like global Moranzai. Okay, so you have multiple options to work with the data you just described with CSV file. You can, let
Yes.
me just list you. You can go with buffer analysis. You can go with network connectivity and corridor analysis. Then you can go for measuring geographical distribution. Fourth, you can go for spatial autocorrelation analysis to understand the, hotspot, cold spot, or even if there is any spatial autocorrelation there or not. Then you can also go for habitat suitability analysis, but for that you need other ancillary data like land use, or maybe connectivity, road pathways, and
So for the
other.
so for this data, we need to have physical data from on the ground level, right? From in-person data. Then we need
In-person
to input.
data you don't need, because you already have elephant occurrence data. That
Okay.
is a field data
So the
I can
movement we
consider.
have the data movement we'll be having for the spatial analysis.
Yeah. But if you can have the, the GPS location of, this species, or some tracking or some camera information, that will be really, ancillary data, really helpful data. But with that standalone CSV data, that can be also, useful. And other ancillary data, I want to say that is like the forest data, wherever, the condition of vegetation, the terrain, how is the terrain. So all this type of ancillary data can be useful for suitability mapping. So you have different options for.
So for different kind of work, we have different analysis systems, right?
Yeah,
Okay.
different kind
So
of
if we
work.
wanted, so if we wanted to, track their movement, we have a corridor and buffer analysis and that type of thing. And then
No,
for their
you
habitat,
can still perform the buffer analysis without having the, tracking data. You just can have buffer analysis with the CSV data.
okay,
No problem with that.
okay.
Okay. But definitely it will improve if you have tracking data, if you have real,
So
field
tracking
data.
data is must. The tracking movement is must for these softwares to, correlate and work.
No, not must. I just saying that it will be better. Your accuracy will be much better, but it is not essential. You can still perform. Sorry, you can still perform the analysis, but providing the tracking data will definitely, help better.
Okay, okay, understood.
Okay.
Thank you,
So,
sir.
okay, thank you. Any more question? Any
So
query?
I have one doubt regarding the last point classification.
Yeah.
Sir, according to the last points, it is classified into too many types like ground, vegetation, noises, and so on.
Hmm.
Suppose unwanted points like noises or overlapping spikes or overlapping points were there. How can we identify and how can we rectify that?
Yeah, good question. So that that is what we are going to do. The analyst is going to do before executing the major processing, right? So there are different algorithms and process like outliers removal, noise removal. So we have this software like CloudCompare. It can actually remove this type of noise automatically. Also manually, you can select the points and you can delete them.
Okay.
Okay, so no problem with that. Like noise removal, whenever the raw data is processed and it is produced the LAS file. Before that, they also run some kind of noise removal, and also after that, during post processing, as an analyst, we can also perform some noise removal method. We already have that.
Okay, sir. Thank you.
Okay, so I hope all of you have downloaded the LASTools and the CloudCompare you have installed. So shall I proceed? So okay, I'm assuming that everyone have downloaded the LASTools. So let me show you how you can actually install the LASTools. So suppose you have downloaded this LASTools with you. And first you have to open QGIS. So you open, all of you, please open QGIS. Sometime it takes time. Yeah. So this is QGIS interface. We are already familiar with this interface. Last day we have done some remote sensing indices and we have done classification. So for this, you have to install the LASTools from the plugins first. Okay. So first you go to plugins. Please pay attention. Go to plugins. Then you go to manage and install plugins. Okay. And under all tab, you have many tabs: installed, not installed, upgradable, new. So you will select all, and here you will just write LASTools. So this is the tool, LASTools. Then you have to first install it. Follow my cursor. Since I already have installed, is there anyone who is not muted? Please mute yourself. Okay, so since I already have installed this tool, so it is showing that reinstall or uninstall, but in your case, it must be showing that install the plugin. So first you have to install the plugin. Okay. Then when it is done, you close it. Okay. So from software end, you have installed the plugin. Now you have to just locate this tool that you have downloaded. So you must have downloaded this LASTool from the drive here. So this is your zip file. So you will unzip this file first. So right click and extract to the file name. Okay, so I'm repeating once again. You select this, right click and extract to, or you just unzip it, okay, extract to the particular file. It requires WinRAR software. Now you have this folder with you. Everything is extracted here. So this is the main folder inside which you can find all the necessary files, beans and all the executable files and application file, everything. Okay, so you need this folder. You need this folder, but not here. Not here. You have to copy this folder. Okay, follow the steps. You select the folder, copy it. Okay, and then you go to C drive. Okay, you go to C drive, and here you paste the folder. Understood? So since I already have the folder here, so I'm not pasting it once again. So paste here. So far, any query or any problem you are facing? Yeah, one have posted one image. I cannot see the image. Let me download it. Yeah, screenshot. Yeah, that is what this because of this problem we are doing this. So you have to address, you have to provide the right location. That's why this error is coming. Not to worry, we will address this problem definitely. And this actually ensure that you have installed the tool from the plugins. Okay, so don't worry, and I will address this problem. So you do this thing, you just copy the last two folder. Okay, this one, this folder, you copy it and paste in the C drive. Okay, paste it, right? So once you have pasted, then you go back to QGIS. Okay, you go back to QGIS, and there you go to settings. You go to settings, and there you will find one the last option, that is options. Settings, then options. Okay, you click on the option. Okay, so on the option there are many tabs on the left hand side, but you will go to processing tab. Click on processing tab, follow my cursor, click on processing tab. Okay, here I hope you are being able to see processing. Now go to providers. Okay, go to providers, and here you will see multiple tools. With along all the tools, you will also find LASTools. See, this is the last tool. Okay, so here you just expand the option. You expand the option, and here you write the right path. Okay, you write the right path. So my LASTool folder is in C drive, and you can see here C:/LASTools/again LASTools. Why? Because I have two folders. Let me show you why I have given two LASTools. If I go to C drive, then I have this folder LASTools, and inside that I have LASTools. Okay, that's why I have given this path. So I go to settings, options, processing, providers, LASTools, and LASTool folder is C drive. This is in my case, but if you are having only one folder, LASTools, then you don't have to put twice. Okay, I hope you have understood. So let me just copy this for your ease. I think there will be one folder in your case, so it will be just. Okay, so if you just write this one, it should work. Okay, is it clear to everyone? Krishanu, your problem is solved now?
Yes, sir, I am working on.
Okay, 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 okay. So, so when you have, provided the right path in LASTool folder, your work is done. Nothing to be, any more work is left. You just click OK, and your LASTool is ready for, every work. So, but how you can, bring the LASTool here? The LASTool is present under processing toolbar. Okay, so you go to processing, then toolbox. First you go to processing, then you go to toolbox. Okay, then you have the processing toolbox, and here if you scroll down, you will find LASTools. Is it there for everyone? Okay, so let me just repeat once again what we have done. So we have downloaded the LASTool folder, extracted it. Okay, then we have gone to QGIS, plugins, manage and install plugin. We searched for LASTools and install the plugin, close it, go back to the downloaded folder, copy the folder, paste the folder in C drive, go back to QGIS, click on settings, then options, go to processing, and there you go to providers, LASTools, you provide the right path. Make sure you are providing the right path according to the folder branches or tree. Okay, then you click OK and you are ready to go. Okay, so I hope all of you have installed the LASTools. So let's start working with LASTools. So we
Sir,
already
once check my
yeah, your screenshot, the last one, or have you provided any new one?
new one.
I can't see. This one you already have provided.
This screenshot is red warning is also
Yeah,
available,
yeah.
but your right side, the processing toolbar under the LASTools is available.
No, if it is the warning is coming, that means you have not located your LASTools folder correctly. So you make sure where you have kept it. For me, just I'm showing it again. C drive. Okay, here is the folder LASTools. Then again, I have another folder. Okay, to make sure, what you do, you go to the address bar and you click, you have the right path. Okay, can you see it? So this is your right path. You can follow the same process. You go to C drive, LASTools, and you go to the folder, LASTool folder, and if you click on the address bar, you will have the right path. And you just copy this path and you go to option, settings, options, processing, providers, and here under LASTools, you can just paste this path. Okay, and you click OK. And if still the warning is coming, you just close the window and refresh it. Once again, you open the window. I don't think you will see the error once again. Okay.
Okay, sir. Okay.
Any problem for anyone else? Okay, I hope there is no problem. So let's start with LASTools. So as I already mentioned, to find LASTool, you have to first go to the processing toolbox. Here, if you scroll down, you will find LASTools. Okay. So before going to LASTools, I just want to open the data here in the main QGIS interface. So how to open LAS file or point cloud file in QGIS? Let's see that. So for that, you go to data manager. So this is your data manager. Follow my cursor. Okay, this is your data manager, this icon. So click on data manager, right? And on the left hand side, you have different options: raster, vector, mesh, point cloud, delineated text, geo package, GPS, and so on. Here we will select point cloud because LiDAR data is a point cloud data. Okay, so select point cloud. Then you locate the point cloud data by clicking on this box. You have to click on this box, this 3 dotted box. Click here and you go to your respective folder. So I have kept my file here, day 2. So let's open any of the format. I have COPC LAS or LAS. I told you about this extension COPC, cloud optimized point cloud, and then LAS format also. Anyone I can open. So let's open this one. Open and add and close. So this is your point cloud data. Now you might be wondering that this is not appear to us as point cloud. This is something seems as continuous raster, but no, it is a point cloud. If you zoom it enough, if you continue to zoom, you will see that it is nothing but a collection of discrete points. So can you see how many points are there? And they are aligned as per the flight line. Okay, so these are the points, and they are also color coded based on the classification code. Okay, now so
Sir,
you have open.
sir, can you please repeat the process?
Yes, so I delete this layer. So I go to data manager. Okay, point cloud. Then I go to this box to locate the data. And wherever I have kept my data, I select the data, click open. Okay, then I click add and close. Okay, so this is how I have opened the data. And if you zoom the data to sufficient extent, you will see it is just a collection of points. Okay, these are the collection of points. So that's why this is point cloud data. But since there are so many points, it's appear to us as continuous or raster. Now the first thing is when you have, imported the point cloud data in QGIS, you have to assign the CRS, that is coordinate reference framework or coordinate reference system. And that is why you can see this question mark on the layer, because CRS is not assigned. Okay, so you have to set the CRS here, although XYZ information is there, but it does not know the CRS. So to set the CRS, right click on the layer CRS, and I am selecting set to EPSG 4326 because I know this data is from USA, okay, nearby Washington city. So that's why, since I know the location, because I have downloaded this data, that's why I can easily search on Google to ask that what is the EPSG code for Washington DC city, or maybe for Boston or New York or whatever region you are selecting. Okay, so since I know the EPSG code, I can select EPSG 4326. So when you download your own data, you have to first search that what is the EPSG for that particular region. Okay, you must know that. So we have set the EPSG code or the CRS
See,
for
I'm not
this.
getting the option. Like I'm getting this
Yeah,
the whole menu.
right, right,
I,
right,
I
right.
am just getting this layer CRS, and then I set the set layer CRS. So I
Yes,
get
yes,
this menu.
right. So you go to set layer S, right? This is
Yes.
your window. Now here in the filter, since I know, you just search 4326. Okay, that is the
Four,
code for
three.
this region. Yes, I'm writing it
Yeah,
in the
I
chat
I
box.
get this EPSG 4326.
Yeah, you select that
Okay.
EPSG 4326, data is WGS 84. Okay, and you click OK. Right? So now
Now,
your layer CRS is set.
okay.
Now, what is the importance? Now you can see where this data is actually located. If I open any base map like Google satellite image, you can see that where this data is actually located. I can show you. If my internet is proper, then it will come. Okay, due to some, let me open this one again. Sometimes it takes time due to the internet. So because both the layers are really heavy, both Google layer, Google satellite, and this layer also. So that's why it is taking so much time to load. Anyway, let's proceed with the the actual viewer for this type of data. Although we can open this data in QGIS, but there are some dedicated viewer for this type of 3D view. So let's open that view. So you go to visualization and colorization. Under LASTools, you go to visualization and colorization. Okay. Under this, you will find LASView. Okay. LASView file. So let's double click on that option and one window will pop up. Okay. Visualization and colorization, LASView file. So here, first option is input LAS file. So I will locate the LAS file here. Now I will leave as it is all the other options. Then I click run. So you are seeing the 3D visualization of point cloud data. Okay, so this is 3D. You will understand why.
Can you repeat the last view? What's the step after that? Last view.
Yeah. Let me close this. Yeah. You first open this option LAS view. Okay.
Yeah.
Then you input the file here. You select the file.
The same file which we loaded
Yeah,
earlier.
the same file. I just uploaded one file that is the one. So then you
Okay.
select the file, then you click run. Okay.
Okay.
So you have this viewer, LAS
Yeah.
viewer. So this is a 3D viewer. So you will understand everything, the rendering process, colorization, and 3D visualization. Just let's wait for the loading. So it is loaded. All the points are loaded.
So this is
Almost.
Chicago, right?
I think this is not Chicago. This is nearby Washington. So if you click on the surface and if you tilt it, you will see the 3D visualization.
Yeah.
You use the mouse click and you can definitely, render the data. Okay, you can see different buildings. Buildings are with, yellow and brown colors. You have noise also. You have blue as water body, green as the vegetation. Okay, you can visualize the data like this. Okay, now you can also change the color type and rendering type. If you right click on the layer, then if you go to color by, and if you select by elevation, if you wish to see according to the elevation information, click there. Only the highest elevation is showing, the light color, and all the ground and lower elevation is in dark red. You can see this. Okay, so this is how you can visualize. You can again go back to color by classification. It will show you the classification, water, building, and everything. It can be as per the intensity of energy received. This is the intensity image. Since this is intensity, that's why it is in grayscale. No color is used. Only shade is used, dark to light. Okay. You can also render the image. If you are, let me change it to classification first. Yeah. Now, if you just want to see the buildings, you want to see the buildings only. I told you the code for building is 6. So if you select only building, it will only show you the buildings. Now, can you see only building? There is no water body or any other feature. So these are only buildings or man-made features. Okay. Now, if you wish to see the vegetation only, so that is 3 to 5. Now you are seeing the vegetation with the right, appropriate color, that is green. So this is the vegetation part. Now, if you wish to see the other, only the ground, okay? If you want to see the ground only, then it will show you the ground. Okay? This is how you can change the visualization, and you can see different feature of your interest. If you wish to see only water, so this is your water part.
In water, what is the represent of void?
This is data sparse actually. Data were not being collected for this part. That's why it is blank, you can say. So data were not collected for this
Sir,
part.
it is for the water reflection.
No, it is just the water surface. The laser beam that is reflected back from the water surface and hitting the scanner. And that way it is calculating the distance between the scanner and the water surface.
Okay, okay, sir.
Okay. So that's how you can actually see different types of features, vegetation, mass point, noise points. Also, you can see if you wish to see the noise points. These are the noise points. You can see some points are even below the surface. So these are noise. Okay. So this is for visualization. So when you are, you have understood the region properly, where is the buildings located, where is the vegetation located, water body located, or other surface is located. You have understood the region, you can go for the other analysis. So you close the window. Now I told you that you can see the different dimensions of this data. So if you just click the properties of the layer, and if you go to the attributes, you will see all the dimensions. Remember, I post one screenshot there with X, Y, Z, intensity, return number, number of returns, scan direction, classification. So all the dimensions are here. So these data are stored for each of these points. And as you can see here, the objects are coded with value, standardized value like ground for 2, vegetation 3, 4, and 5, a building for 6, and it also has a standard color. So these colors are standardized color, not any arbitrary color. So everything is classified here. Okay. Now maybe you don't know the information about this file, the metadata of this file. Now you might wish to know the information. In that case, you have to go to data quality and control under LASTools. Okay. So here you select LASTinfo. Remember, I am just using some selective tools because these are open access. Okay. So LASTinfo, you double click on the option and then you select the file, open the file, and you run it. It will take some time since till this window is there. That means processing is ongoing. You can also see the processing here.
Repeat the.
Yeah, you go to LASTools, then quality control and information, then LASTinfo. Okay. So once it is done, it has returned lots of information and metadata. It can tell you that this ground is 2, the number of points associated with each of this type. For ground, you have this many points. For low vegetation, you have this many points. For medium vegetation, the code is 4 and you have this many points. So you can understand the statistics also, that how many points falls under each type of feature. Okay, so it can tell you the other information as well. Okay, so this is to know about the data, know about the statistics of the last data. Okay, LASTinfo is used. So you could close this window. Now let's do some extraction process. So I wish to extract the building first. Okay, so I want to create one layer which will have only the building, and with that layer you can do further processing, like you can go for building footprint analysis, or maybe you can measure the volume. Okay, or maybe you just want to build the model for building only, 3D model. Okay, to extract anything you have one tool called las to las. Okay, las to las, LAS 2, numeric 2, then las. This is a kind of a filter. Okay, it's a filter. So las to las filter for the file only. So I select this option and this comes under data convert and import. So double click on this option. I select the las file again, open it, and then you have to select the particular feature you want to extract. I want to extract building, and I know for building the number code is 6, right? So keep class 6. Okay, if you want to extract anything else, you can also further add here, but I just want to extract the building, not anything else. Now whenever you have selected the code for building, now you have to save the file. Go to this part, output, then you save the file. So I want to name this file as building.las. Okay, because this is just the building layer. Now I save this file. Now I hit run. Okay, again it will take some time because this is a very huge file. So whenever this process is done, you will ended up with a layer that will have only buildings, not anything else.
I just keep the class 6, right?
Yes, keep the class 6. Now it is done. So let's open the file. You can open here also, and if you wish to open in the last viewer, that also you can do. Let's open this in last viewer because that is the dedicated tool for visualization of LAS data. So I go to visualization and last view, and here I select the building file, click open, and I click run. So see, there is no other feature present in this file. You only have the building, and according to that, you only have YOLO because that is the color, coded for building. So you can see the buildings, all the buildings, nothing else. No, neither any water body or anything else. Now, when you have dedicated building layer, you can further make it a raster layer. We will learn that you can prepare a digital surface model of building, and then you can have other analysis only for the building. Okay, so this is the building layer. Now, similarly, if you wish to extract the vegetation or maybe water, so follow the same tool, LASTools filter. Again, you select the LAS file, the original LAS file. Then you go to filter. And for vegetation, we know that the codes are 3, 4, and 5. You can also select individually. If you just want the low vegetation, you select 3. If you want the other vegetation, medium vegetation, you select 4. But if you want all the vegetation to be present, you select 3, 4, and 5. Okay. You have selected keep class 3, 4, and 5, and you just run. But remember, this time we have not saved it anywhere. Now it is done. Again, if you open the, not here in last view. Yeah, I think this one. I have not saved with any name. That's why it has automatically taken one name. So let's open this, run. Yeah, here you can only see the vegetation, just like the previous one. You were seeing the buildings. Now you are seeing the vegetation part. And following the same process, you can extract water body. You can extract whatever feature you want. Okay, so this is the extraction process in QGIS and with the LASTools. Okay. We have many other tools we will discuss in the next day, especially generation of DSM and DTM. So for now, I would like to go to another software we have to do the same thing with CloudCompare. So I hope you have installed the CloudCompare. So I'm closing this. So let's open CloudCompare. So this is the CloudCompare interface. This software is specifically built for processing with the point cloud data and correcting the point cloud data, removing noise, filtering, and to produce raster from point cloud data. And by point cloud data, it is not only for LiDAR data, but also for photogrammetry purpose. So for photogrammetry, we also use this software for, editing and for modifying the point clouds. Okay, so this is the software interface. In this blue section, you will be able to visualize the data, and you have DB tree here where you will see all the layers. And in the property window, you will see all the properties of individual layers. Okay, so let's open one data, and you also have multiple tools on top, on the right ribbon, and also on the left hand side you also have many tools. So let's open one data. To open any data, you can use this option.
Actually, I am facing problem in installing this. Actually, it's saying it's expecting some path of
Okay,
VCRE dist something.
okay, so can you share the screenshot? I will understand better with that.
Yeah, yeah,
So
I'll just share that.
share the screenshot. Anyone else is facing any problem related to this?
I just copy pasted the exe file to the C users.
No, you just for CloudCompare, you can just execute the exe file. You double click on the exe file and you then click next, and it will complete the installation. For CloudCompare, you don't have to copy paste anything anywhere. Okay.
So how to launch it? Like actually,
After installation, you just write CloudCompare on the start menu, and it will show you the application. And you click on the option, it will open automatically like this.
actually it's not installing.
Okay, what it is showing, the screenshot you have shared.
Yeah.
Okay.
Should I download and
Yeah, you should. You also make sure that your operating system is 64-bit.
yeah.
It is 64-bit, right? So, uh,
It can be installed anywhere, right?
yeah, it can be installed anywhere.
No worries. I think I'll catch up.
Okay. So, even after this, I will address this issue of yours. So let me just finish this session, then whatever problem you're facing regarding installation, I will
Yeah,
address
no
this.
issues.
Okay. So since we have very limited time, so let's open the data. To open any data, you go to File and Open. You can do that, or maybe you can just click on this icon. Open one or several files. Then you go to the drive and wherever you have saved your data. Then you locate your data, select the data and open. Okay. Whenever you hit open, all these parameters, it is asking whether to load or not. So you just apply to all. And then another window comes to ask you whether it wants to perform the global shift of coordinate system for its own convenience, because CloudCompare works better with smaller value of coordinates. That's why they want to convert each of this coordinate into global shift. Okay, so you just hit yes to all. So it might take some time because it has so many points. Okay, so meanwhile, if you have any questions or query related to this, or so far we have whatever we have discussed, you can ask. So the data has opened here, you can see, but in grayscale, in black and white, because it is actually in intensity dimension. So you can change that. If you select the layer in the property window, you have different options. So here you can change the field, whatever you want. You want the classification or you want the intensity. So this color, current color, is based on the scalar field, and the scalar field is here is intensity. Okay, so we don't want intensity here, we want classification. Okay, so we want classification, and this classification is utilizing the American Society of Photogrammetry and Remote Sensing code, ASPRS classes. You can also, if you wish, you can also label the class, and you can see the labels. This color is denoting water, this one is this one is road or something else. So this is your data, 3D visualization. You can also see many noise and outliers are there. Like this one, you can zoom in to check the noise and outliers. So someone was asking about removing the noise. So we can actually remove the noise here. But my recommendation is you first reduce the data amount, because you have so many points. You have to have a part of the data. You must cut out a portion and then work with that. That will be much more faster. Instead, if you work with the whole data set, that will be very much comprehensive and heavy processing will be there. So it is better that you reduce the amount of data. So to do so, if you want to cut out a part, what you have to do, you have to select this option. Please follow my cursor, an icon with scissors. Okay, scissors. You first select the layer and then you click on this scissor icon that is for segmentation. Okay, then you have to select a polygon. So I select a rectangular selection. You can also select a polygon of your interest, study area, or whatever you want. So here I just want a rectangular or square shaped boundary. Now I have completed drawing the boundary. Then I have to click on this option, that is segment in. So when you click on segment in, it is only taking this part, cutting out this part. And when you are happy and satisfied with your small part of the study area, you just click on this tick icon, this tick, that is confirm segmentation, enter. Okay, click here. Now when you click on the confirm, you have another layer with you on the DB tree. Okay, so one layer is the previous one, another one is segmented. Okay, so for now I don't need the whole layer. I just right click on the layer and I delete the layer. I just want this small part. Okay, so this is my part where I will execute everything. You can see some outliers and noise. Buildings are there, high-rise buildings, some small buildings. Okay, now you can also change this view by clicking on this option. If you want the top view, you follow my cursor, you click on set top view. Okay, if you want the front view, you have this, you click on this. side view, left side view, then the back view, right side view, okay, the bottom view, and front view also, and back view. So you can also change the view whatever you want, or maybe with the mouse you can also change this view. So there is no issue. Now here I have selected scalar field for the colors, and my scalar field is classification. Okay. And if you just scroll down, you will see the scalar field display parameters. Okay. And here the value ranges from 1 to 20. And remember, these values are actually codes. Okay. So if you just put here from 2 to 3, it might just show you the ground. If you just put here from 5 to 6, it might show you just the buildings. Okay, so you can check that. So let's change the value. Let's make it 2. That way you can only see a very portion which is not coming. Everything is getting gray. So you can change this value. You can increase the lower threshold. You can also increase the upper threshold. If you make it 3, let's see, you can see only some of the ground part. If you make it from 2 to 3, so that way you can actually see what value is visualizing what part. You can change the value. Now if you just want to see the buildings, then you make it 5, let's make it 6, and make it something. You can also drag this part to adjust the value. So now you are seeing only the buildings. Okay, so that's how you can actually visualize different objects, and also you can filter this. But before doing that, I just want to remove some noise part here. There are some outliers and noise. I want to remove this. How to do that? You go to tools, select the layers, you go to tools, then you go to clean, and then you have two filters called noise filter and SOR filter. So you click on noise filter, keeping all the parameter as it is. If you just click OK, it will do some noise clearance. You will be able to see the difference. Okay, so while this is processing, you can, if you have any question, you can ask, or if you are facing any problem, let me know. So it might
I
take
think
some time.
mine, I installed it, so it's okay.
Okay,
It's working.
okay, good.
Only
Good.
thing, like, what is the preferred tool? Like, we go for Cloud Compare or QGIS for
Yeah, see, both the tools are, capable of doing things, but uh, I think LASTools is much more, comprehensive than CloudCompare. CloudCompare has some limitations,
Okay.
It can definitely produce raster layers, like for noise clearance, for filtering the outliers. You can use this, but for creation of digital elevation model and digital surface model, LASTool is better. And also, some tools under LASTools are not free; they are licensed. So this is the limitation of LASTools. So you can use both the software, but when you are using the digital surface model, it is better you use the LASTools.
Okay. So if we have to go for preparing a DEM model, you will say go for LASTools.
Yeah, it is better to go with the LASTools, but
Okay.
yeah, but you can definitely prepare the same in CloudCompare also. Yeah, it has what? So now I have the noise-free data. I can show you the difference. This is your the previous data. Let's change the visualization. Let's make it from 1 to its fullest extent. Yeah, and let's make it as per this one. So we can see some noises are eliminated, removed. Yet you have some noises, but you can also manually clean that, or you can use the outliers options. Okay, so if you want to clear the outliers, you go to tools, clean, and you again go for SOR filter. But make sure that you are selecting the clean version, which you just have cleaned, not selecting the previous one, but I have mistakenly selected the previous one. I don't know. It will work, but not to that extent. Yeah, now the outliers are clean. You can see much more clean data here. This one was the initial one, and this one is the without outliers. Okay. Now, if you wish to, extract the building and vegetation, just like, QGIS, you have options here also. What you have to do, you have to select the layer, and then you have to select this option, filter points by value. So if you click here and if you select the right value, like if you want the building, you must select 5 from between 5.5 to sometimes take between 5, and you take between some 6.5, and if you split it, yeah, this one is the building part you have extracted. So here also you can extract the building part. I have not taken the value properly. Some vegetation also have came under this, since I have taken 5. So I should have taken more than, nearby 5.6 or something like that. So since I have taken 5, so some vegetation has also incorporated here, but my intention was to filter out the building only. And this is the remaining part. Okay. Now let's again filter out the vegetation part. you use the same option, filter by value. For vegetation, I select 3, 2, 5. Now you split it. Yeah, now you have the vegetation part. Okay, only the vegetation. Now, if you wish to save this file, definitely you can save this file. You select the file, go to file option, and then you save it. Save it as vegetation dot las. You save it, click OK. So your layer will be saved. Okay. Same way you can also save the building part also. Similarly, this is the building. You can also select the layer and you follow the same thing, file and save option. Okay. And you save the file. So that's how you can extract different features, building or vegetation or any other features. Okay. Now I have covered the processing part for today. Next day, we will discuss about the preparation of digital surface model, digital terrain model, digital elevation model. And one more thing, I would like to just show you that how you can download this data. So I mentioned many sources. One of these sources were National Map Downloader. So you just go to this website. I'm just writing in the chat box, this website. Okay. So here to download the data, you have to select the data first. That is elevation source 3D EP LiDAR data. So you select that. Okay. Under this, you select LiDAR point cloud data. Now you want to show for which area it is actually covering. You click on show. So this green part is actually the coverage. So if you go to any area, like if you go to this part, so you have to select your study area first. So you go to extent or polygon. I select extent. So just select an extent. Okay. And then you hit search product. Right. So you have many products you can see here. You can download. If you click on download download link LAS, it will be automatically downloaded. Okay, just let me show you. If you click here, so the data will be downloaded. So you download your own data and try this process in the coming week. Okay, you practice this and let me know if you face any problem. And for today, I would like to conclude the session and over to you.
This is working for India also.
No, this will not work for India because this does not have global coverage. As I already mentioned that for LiDAR data, you don't have open access data regarding LiDAR. For learning purpose, you can download data from USA, Scotland. Some regional data are available. You can use that data to learn. Okay, but for India,
Bhunidhi also doesn't work.
not freely available data. You can put requisition. If they have any project LiDAR data, then they can provide the data. Okay, but not open access. Okay, so thank you everyone. If you face any problem, please let me know even after this session. And over to you.
Okay,
Thank you, sir. So I
Thank
hope that's the closing of today's session. Thank you so very much, sir, for such an insightful and enriching session. And on behalf of Indaca Institute of Skills, I would like to express our sincere gratitude to Dr. Suman Chatterjee for sharing his valuable knowledge and expertise with us today. I would also like to thank all our participants for their enthusiastic participation and active engagement throughout the session. Your curiosity and interaction made today's learning experience more meaningful. We encourage everyone to revise today's concepts and come prepared for another engaging and practical session. Once again, thank you, Dr. Suman Chatterjee, and thank you to all the participants for being a part of this workshop. Have a wonderful evening and see you all in the next session. Thank you and goodbye.
you. Thank you. Thank you.